In this video, we're going to find probabilities of some given arrangements. Here's the scenario that we're dealing with. On her vacation, Riya visits 4 cities A, B, C, and D in a random order. What is the probability that she visits A before B? Which means that the order in which she visits has A before B. A comes first. Pause the video, give this a try. Alright, let's do this together. So, one way to do this is list down all possible arrangements. We have A, B, C, D. If we arrange all of them, that's 4 factorial ways. That's 24. Here's the list of all 24 orders. 6 times 4, that's 24. Okay, let's first manually count all the possible arrangements where A comes before B. Do we see it? We have these 6 where A comes first. So definitely A comes before B. In fact, A comes before everything else. Then we have these 4 where A comes before B. For these 2, A comes just before B. And for these 2, A comes before D, which comes before B. And A comes before C, which comes before B. Do we have others? Yes, we have these 2. A comes before B. And that's pretty much it. So how many do we have? 6 plus 4 plus 2, which means 6 plus 6, that's 12. So probability of A before B, that's favorable by total, that's 12 by 24. That's half. So there's 50% chance that Riya visits A before B. But is there another way to think about this? Definitely. Let's think about this scenario C, A, D, B. If we fix everything else and just flip A and B, we'll get C, B, D, and A. These two are in a pair. In one case, we have A before B, and in the other case, we have B before A. And that's the case for all such pairs. Half of these will have A before B, and the other half will have B before A. That's why we're getting the probability 50%. Let's try more. Here's another scenario, A before B and B before C. Pause the video, try this out. Okay. First, let's manually check. A is before B and B is before C. So we'll take this one, A, B, C, D, that works. This one also works, A before B and C is last. So A, B, D, C, that works. Do we have more? Yes, this one, A, D, B, C. Where else? We should have A, B, and C in this order. Here we have D, A, B, C. So total favorable outcomes, that's 4. Total outcomes, that's 24. Probability is going to be 1 by 6, 4 by 24. Again, is there another way to think about this? If we have A, B, and C and the order is set, A will come before B and B will come before C, where can D be? So for D, we have these options. It can come before A, between A and B, between B and C, or after C. So there are these 4 options for D, which is why we're getting these 4 cases, 4 arrangements, where A comes before B, comes before C. D has 4 options. If D comes first, we'll have D, A, B, C, this one. If D comes second, we have A, D, B, C. If D comes third, we have A, B, D, C. And if D comes last, we have A, B, C, D. Alright, let's keep moving. A first and B last. Pause the video, try this out. Okay, A first, which means we're looking at these 6. And in these, we have B last, which means this one and this one. So A first and B last. That's it. So total favorable outcomes, that's 2. And total outcomes is 24. 2 by 24 is 1 by 12. That's the answer. Is there another way? If we have A and B, A first and B last, where can C and D be? C and D can be in one of these places, and they can arrange themselves in 2 factorial ways. This is why we're getting the total favorable ways as exactly 2. In one of them, C comes first, and in the other one, D comes first. CD and DC. Alright, here's another one. A either first or second. Pause the video, try this out. Okay. Either first or second, both of these will work. So these 6 definitely work. A is first here. Now let's see where A is second. It's these 6. Here A is in second place. That's it. In no other arrangement, we have A in either first or second place. So the probability is going to be 6 plus 6, 12 divided by 24. That's going to be half. And again, there's another neat way to think about this. We have these 4 slots, 1, 2, 3, 4. There's a 50% chance that A will end up in these 2. 2 divided by 4, that's half. This is why we're getting the probability of A either first or second as exactly half. Here's the last one. A just before B. Pause the video, try this out. Okay. So A just before B, which means we have AB as a combo. So ABCD will work, ABDC will work. Where else? We have A just before B. This one works, CABD. This one also works, DABC. Where else do we have A just before B? These two, CDAB and DCAB. And that's it. So 2 plus 2 plus 2, that's 6. So 6 by 24, that's 1 by 4. So the probability that Riya visits A just before B, that's 1 by 4, that's 25%. Another way to think about this is AB is a bundle. Let's call this X. And there's only one way to make this bundle because we want to make A first and then B second. We will not have a BA. So AB is a bundle. This is X. Now we have these three cities, X, C, and D. They can arrange themselves in 3 factorial ways. That's where we're getting this 6 number.